Welcome to Mr. Primus class. Let's look at chemistry. Mass, mole, volume relationship. The volume we are going to look at today is at S.T.P. S.T.P. Volume at what? S.T.P. I want to ask you, what is the full meaning of S.T.P? Do you know? It is standard temperature and what? Pressure. So a standard temperature and pressure. S.T.P. Standard temperature and pressure. So we are going to look at mass, mole, volume relationship. Alright? Volume and mass mole relationship. Now, in a very simple way, I want to give you what you need. The relative atomic mass or relative molecular mass of a substance is equivalent to 1 mole of that substance, and 1 mole is equal to 22.4 dm³ of gas at S.T.P. If it's a substance, the relative molecular mass of the substance is equal to 1 mole, and 1 mole of a substance is equal to 22.4 dm³ at S.T.P. This connects the three of them. I know we have talked about relative molecular mass. If you've not learned it with us, you can check our previous videos, or you can still request that we do it again. So now 22.4 dm³ or 22,400 cm³, either of these two. So 1 mole of any gas at S.T.P. occupies 22.4 dm³ by volume at standard temperature and pressure. We are still going to learn gas laws here, so that we'll talk about standard temperature and pressure. I don't want us to talk about that now, so let's just focus on these. Now you can have a question like, calculate the volume of carbon dioxide liberated when 50 grams of calcium trioxocarbonate 4 is heated at S.T.P. standard temperature and pressure. The volume of this is a kind of question you see always. It comes out most of the time. A question like this. So if you can solve it, you'll be sure of 1 mark. With other ones that you are going to learn, your marks keep increasing. So let's solve this solution very carefully. The first thing we do, calcium trioxocarbonate 4, when you heat it, it decomposes to give us. I've taught you how to write and balance chemical equations. You can still request, we'll do it again. I will do it for you. So when you heat this, you have calcium oxide and carbon 4 oxide. If you look at this now, it's balanced. So now the first thing we have to do is to get the relative molecular mass of this, and the relative molecular mass of this, and the relative molecular mass of this. So let's get it now. I just want us to take it easy. Gradually you will get it. So now, you know the atomic mass of calcium is 40. Most of the time, all these atomic masses are given in parentheses, in brackets. Plus, the atomic mass of carbon is 12. Plus, oxygen is 16, but it's 3 atoms here, 3 atoms of oxygen. So, 3 times 16 is what? 48. Molar mass, when you add all of them, you get the molar mass. That is what? 100 grams. 40 plus 12 is 52, plus 48 is 100 grams. This calcium is 40 plus oxygen is 16. That is what? 56 grams. Carbon is 12. Oxygen is 2 times 16. 32. That is what? 44 grams. You can see that now we have the mass of the reactant or this compound and the products. Look at this. Alright. So the question says 50 grams of calcium trioxocarbonate 4. I've taught the students this a number of times. The best you have to do is to 100 grams. This one is nothing is about this one, so we are going to leave this one. 100 grams of calcium trioxocarbonate 4 produces 44 grams. So now 50 grams will produce how many? 100 grams produces 44 grams. 50 grams will produce how many? When we put these two together, we get what we call reacting mass. Alright, reacting mass. We now move to mole. 50 grams, so write it. 100 grams produce 44 grams. 50 grams will produce, you cross multiply 50 times 44 divided by 100. 50 times 44 over 100. So 0 cancels 0, 5 and 10, 2, 2, 1, 2 in 44, 22 grams. 100 grams, 44. 50 grams will give you 22 grams of carbon 4 oxide. Now, this is what we call reacting mass. It is that mass obtained or the one given in the question. So we are going to come into mole now. We have talked about mass. So if you are asked a question like, calculate the mass of carbon 4 oxide produced by heating 50 grams of calcium tricarbonate 4. See the answer. This is an answer. So I'm teaching you 3 in 1 question. So this is an answer. 22 grams of carbon 4 oxide is produced by what? 50 grams of what? Calcium tricarbonate 4. So we'll now proceed. We'll move to the next one. Mole. Mole. Let's look at formula for number of moles. Number of moles is equal to reacting mass over molar mass. The reacting mass is the mass given in the question or the one you have obtained through the reaction or by the combination or the products or whatever we may have it as it may be. Now, you can now have the number of moles. You can write it in short form like this over molar mass. So our reacting mass is 22 grams. Our molar mass is the mass of CO2. Mass of CO2, that is what? 44 grams. So 22 grams divided by 44 gives us what? 0.5 mole. See, we have converted. So if you are asked how many moles of carbon 4 oxide is produced when 50 grams is heated, see the answer, 0.5 mole. Right? So let's finish this thing here now. Here, let's finish it here now. So we have moles. Now, 1 mole of a gas at S.T.P is 22.4 gm cube. Now, 0.5 mole will give us 0.5 times 22.4. 0.5 times 22.4 will give you 11.2 dm cube. This is that volume in dm cube. Thank you very much. You can see that we started with mass, we moved into mole, moved into volume. Then we have this. So we are going to do this again and again with similar questions that are a bit technical. The next one, I'm going to give you an equation that involves combustion of the hydrocarbons. We did it in our last video, so go and check that video. Combustion of hydrocarbons. We are going to use the equation. We'll balance it and find the volume of carbon 4 oxide that can be liberated when a mass of a given hydrocarbon is is burnt, like when you burn it, like when it reacts with oxygen, what you are going to have. That will be our next video. Thank you very much.